today I want to talk about TDD, so test-driven development with a special focus on Android. So maybe first question, who here in the room is an Android developer? Okay, good idea. And who here has some experience with test-driven development? Huh? Glad to see that we have a few. Okay, then I have like a rough idea. You know, my journey in testing started many years ago. Actually, I found this slide lately. This was the very first presentation I gave about testing. It was a BlackBerry developer conference somewhere in California, and it was the year 2008, so Android just started back then, and I was talking about unit testing. But to be honest, from that presentation until today, where I do TDD on a daily basis, it was a long journey. So maybe if this talk helps a bit, like shortening the path for you, I will be happy. Because for me, TDD is the best way to write software. It's the most effective way. But as I said, it was a long journey. I think we can skip this. The only thing is I've been to Russia before, but it's the first time in Nizhny Novgorod, so I'm happy to be here. So let's start then talking about testing. You know, the reason I wanted to give this presentation was I've been to TDD presentations before when it comes to Android. There are some really good TDD presentations out there, but hardly anyone for Android, hardly any. And I've been to a few, and most of the time they talked about testable architecture, how to write testable code. I already knew this. I gave presentations about this. What I was interested in, what is this TDD thing exactly, right? And this is why I want to talk about this here. And to understand TDD, we have to talk about testing. So, to be honest, I think every mobile developer kind of had read this book, especially every iOS developer sometimes, I feel. So there are so many excuses why we should not write unit tests, and it things like, I don't know, I've written this code, I know it's working, right? Why should I test? We have QA for this. There are so many weird things that people say that when you talk like a Java backend developer, they would never think something like this. But somehow we think in the mobile world, I don't know, this is just UI, there's nothing to test. No, it's not true. You all can write unit tests, and ideally, let's do it test-driven. So here are a few quotes from some of our heroes. So Michael Feathers said, code without test is bad code. Whatever you think of your code, if it doesn't have a test, it's bad. And actually he said, and this is a very famous quote, any code without test is a legacy code. And that's the guy who wrote the most famous book about legacy software. So if you written code, and if it's 5 seconds ago, this is legacy because if you don't have test. So think about it. Or let's talk about Uncle Bob. He said, how do you know something actually works when you don't have a test? Maybe it worked now, but will it work tomorrow? Will it work in a week? You don't know. You have no idea. How about this one, Martin Fowler? Refactoring without test coverage is changing shit. And to be honest, this is one of my favorite because developers often think that testing is about functionality. For me, it's not. Yeah, it's nice to make sure that the functionality actually works. But for example, I started SoundCloud like 3 months ago, and we have an 8-year-old Android code base. A lot of developers were on this code base. There are a lot of frameworks there. There's things there that were used like 8 years ago. They're still there. But we have a lot of tests. And I feel really comfortable going through the code with a machete and cutting out parts and changing things because there are tests. So, and often I break things, but the tests tell me. So tests are really, really important if you want to have a long-term relation with your code base. But let's talk about TDD. So testing is one thing. TDD is like I said, like it's kind of the next level. So what's the whole TDD thing about? We have it all goes back to Kent Beck and his book about extreme programming. Maybe you never heard of extreme programming, but you know, heard of Agile. And in the 90s, like Agile and extreme programming kind of happened at the same time. Agile was more focusing on the projects, while extreme programming focused on us developers. And a lot of things that we do nowadays, like pair programming, continuous integration, all came from extreme programming. And in there, he talked about test first. The interesting thing is that it was kind of a rediscovery. When you talk to developers from like the really early days of programming, like the 60s or so, when there was only a few developers worldwide, they would do test first. It was the only way they would write a program. It was completely stupid for them to not write a test first. It only became after like all of us came into IT, like in the 90s and 2000s, that things changed actually. And then the whole TDD thing came up when Ken Beck wrote this book, Test-Driven Development by Example, which started the whole TDD movement in the year 2003. So how does it work? In the daily work of TDD, we have like two things you have to know. One is called a nanocycle, one is called a microcycle. One happens in seconds and the other thing like in minutes. And this is the way we work. So let's talk about it. So the 3 rules of TDD, and this is the nanocycle. And I show you. If you don't get it, don't worry. I will show you examples. So you must write a test before you write any production code. Do not start a single word, not even word class or anything. We start with the test. And then you must not write more of a test than is sufficient to fail. And you know what? Not compiling is failing. So this happens in seconds. It might sound weird, but this happens all the time when we do TDD. And then we write not more of production code than is actually needed to make this failing test pass. And making a compile is already fine. Stop. Go back. So this is a continuous cycle we do. And this is embedded in the second thing, and this you might have heard. This is also known as the red-green refactor steps. If you see like TDD videos by Uncle Bob, and you find them online, you see him, he has like a hat with like 3 sides. One is red, green, and one is, I think, yellow. So red-green refactor. So the whole idea there, and this is the actual TDD cycle, you write a unit test that fails first. This is very important that it fails, because otherwise you will not know if your test actually works. I've written many tests, and then was so convinced this will work, and then, wait, this should have failed. There's something wrong in the test, but it's all green. So it's important, make the test fail first. Then we write just enough production code to make the test pass, and we will stop. That's all we do. And you know, then we clean up the mess that we just created. Because that's very important. So refactoring is part of your cycle. You do a continuous refactoring. So make it fail, make it work, and then make it right. These are the 3 steps. And you probably now think, what the fuck? How can anybody work like this? Seriously? So let's talk about it. This is actually based on science. So our mind, our brain, is not capable of doing the 2 things at the same time, the behavior and the structure. We might be able to really make it work, but also make the best possible code at the same time. It doesn't work. So we'll always mess it up. That's the idea. Let's split it. So you need a red phase, as you have to know that your test works. But the nice thing in the green phase, in the second phase, is this speed trumps design. You will make this test pass as fast as you can. You know this colleague who always writes the most hacky code, and everybody loves him because he's super fast? In the green phase, you're allowed to do this. You can make whatever makes this test pass. You can make really dirty code. Because just like a minute later, you will clean this up in the third phase. So this is the nice thing. This can be actually fun. Then the thing is, you always do one step at a time. And you really focus on this one step. So making it work, making it right. Important, don't get distracted. Actually, there was in the book from Ken Beck, he says, you know, sometimes this happened. We have like a thought, and we are following this, but it's very important that don't distract the distraction. This is his magic rule. Sometimes happens, and we do a second thing at the same time, but never go to this path, because you will end up in this rabbit hole. So you think of a new test, write it down. I normally have like a commented list in my code base, actually, and say, oh yeah, I also have to test this. And then I go back. It's like meditation, like acknowledge the thought and then go back to where you were. It's getting ugly. Write it down. Yeah, I need to clean this up later. Keep going. Don't get distracted. That's very important. And the nice thing with this red-green refactor is you're always one step away from the green bar. So that means you can actually have really small pull requests later, because you can basically commit all the time. So how does this actually look like, right? This is like, sounds like a nice theory. This will not work, right? Let's look at some code. So how do we start? For a lot of developers, this is the biggest problem. Like, okay, I get it, but where do I start? What do I test? Right? I always start with this every single time. I write a test. I don't even have a name because I don't know what I will test. But I have to start with this. Actually, it should start with fail because we need a failing test, right? So, but we start with a test. And then you think, most of the time you know what you want to write. You know it, right? And the thing of TDD is stop. Now we will write the test that forces us to write this code that we already have in mind. So let's do this. I want to write an Android app, so I probably need an activity. Like a main activity. It doesn't compile. Stop. Nanocycle. This is the first step. We have to make it compile first. How? How about creating the class? Cool. It compiles. Next step. This is not an activity, but this is the nanocycle. I do this in seconds. Okay. I probably need to make sure that, I don't know, a create activity. So let's call on create. Doesn't compile. Stop. Let's make it compile. For example, like this. Cool. I mean, this is not a test yet, right? But we're still in nanocycle. We haven't fulfilled the first microcycle. And then I know what I want to test. I want to make sure that this one inflates a layout. Cool. So let's create an activity, call on create, and make sure that I do this set content view, which is binding our activity, like our screen, to a layout file in Android. And okay, it doesn't compile. Let's create this layout file. Use your IDE, right? I mean, you don't have to type all of this. Okay, done. It compiles. We are still in nanocycle. But now we have actually an test name, right? So I changed the test. Okay, this doesn't, this fails actually. I have a failing unit test. Oh yeah, this is because the activity I can't call verify. So let's fix this by making it a spy. This is a very ugly test, but this just shows you how you can get started. We run it, still as a red test in a microcycle, because I haven't done anything in this activity. Sure, let's edit. And I have a green test. I fulfilled my first microcycle. I write myself a test that forced me to write a single line set content view main activity and create a layout file. There's nothing in the layout file, but I don't care here at this point. Maybe write it down. So this is how I do TDD. This is actually a test I wrote when I wanted to be really, really strict with these, what we call baby steps. I mean, and in practice, we are pragmatic, right? We will not always do all of these things. But when you get started, following these baby steps is really helpful to get into this mindset. So remember, write a test that forces you to write the code that you want to write anyway. But afterwards, you have a test. And always create like a list of tests, for example, on paper or on a Java doc. So you probably think, come on, seriously, this is how you work? This must be super slow. How can you write any code like during a day, right? I have like 8 hours working day, and by the end of the day, I have like 3 tests on 3 lines of code, right? So let's talk about speed, because it's the one perception that everybody thinks about testing. Like, I don't have time for this. This takes, my boss will not allow it. Like, the customer will not pay for tests. Let's talk about it. I have to admit, writing tests is slower than not writing tests. I think this is true, and we all can agree on this. And yeah, if someone tells you otherwise, no, that's wrong. And you will write at least as much test code as production code. Probably much more. The nice thing is, you will probably write less production code than you would write normally. But there's also research that showed that the initial cost of a project, when you do TDD, increases by 10 to 30% because of the tests that we write. That is longer to complete the project, up to 1/3 longer. That is big, right? That's a big problem. But the same research also shows that the defect density, so these are the tests that you, the defects, the bugs that you find during development, like your QA department, for example, reduces by 60 to 90%. That's a big difference here that depends on the studies. Like, different studies have different results. That's why it's 10 to 30, and here it's 60 to 90. But even 60% is pretty good. But even more important, the production bugs went down from 40 to 80%, somewhere in between. And even like reducing all your production bugs by 50%, that might be worth this initial effort, isn't it? And it's actually studies you can look up. So the thing is, with our TDD, you spend a few weeks writing code, right? Which mostly works. That's what we do all the time. and then spent the next year trying to fix all of this. With TDD, you spent a year just writing code. That always works. So you continuously chip, and actually, the longer a project takes for me with TDD and with tests, it still is fun. Normally, you get slower and slower, and it's just painful doing any change. That's not a problem if you have TDD in the first place. So, yes, a single feature, an initial feature, will take longer. Your bug fixing phase will be much shorter if you have one. At SoundCloud, for example, we don't have any QA. It's all the developers who has to do it. So testing is really important for us. One thing I like is debugging disappears. Do you like to debug? Maybe you enjoy it, like a puzzle-solving question. I hate the debugging. And often I don't start any device or emulator in a day. Your CI finds your bugs before your QA or before your customers will do. And long-term, TDD is always much faster because you will not coming from this one rewrite to the next rewrite to the next rewrite. This is what we basically do all the time, right? There's more benefits. Like, you know these rules, like you ain't gonna need it and keep it simple, stupid. You get these out of the box. I'm not allowed to write any more production code that is needed. I cannot over-engineer this. So I've seen like really talented developers who wrote a super generic code that no one understands. But they think about all these possible use cases in the future. We are not allowed to do this anymore. I have to stop the moment I test the screen. And you also test all your business needs, because these are the tests that you write in the first place. Again, minimize debugging, that's a very important one. And we are Android developers, minimize the use of Android devices, because that slows us down. And you know, what I really like, the whole thing is a bit like gamification. It's actually fun doing TDD. So there's videos from Uncle Bob where you can watch him for an hour coding. There's one on YouTube where he codes Kotlin. And he really has fun doing this because he said, yes, I made this test green. I'm a developer. I did it. And the same with the test. Like, okay, how can I make the next test red? What did I miss? It is really like, it's a fun way of coding. You do these small changes, so you have super small pull requests. That means your colleagues will be very happy. As I said, ideally, you can commit all the time. There's actually an exercise that you can do where you have a timer. And after this timer, you have to revert to the last green commit that you had. You can only commit on green. And the time is over. There might be like 90 seconds. Need revert. And probably the way you normally work, you will not get any work done in this hour. If you do TDD, it's very easy. Yeah, just go back to the last one. I probably failed. And I do where to start next. Which is the important thing. You always know what to know next. There is a nice presentation you can also look up. I have the links later in the presentation. It's called TDD for those who don't need it. And it's a developer who hates this whole TDD idea of like, some people think it's very religious, and there's a software crafters community who really pushes for TDD. And he said, I don't want to be part of this. I don't like TDD. And then he came to an interview, and they forced him, like, as a coding task to do a pairing session in TDD. And he said he came out of this interview, and he actually liked it. And he thought about, why did I like that? And he went into TDD, and he said, you know what I do when I'm done with my test, when I've written a test? I close my laptop and go home. Because you can do this all the time. Because TDD is actually, I can say this for myself, it's a much stressless way of developing. It is not as stressful as we normally have it, where, oh shit, I have to do this and this and this and this and this. No, you have a test, you know what to do next, okay, close the laptop, go home. So go home anytime, and interesting, be interrupted anytime. You know, developers have this need for the flow. They need to come into the zone, or whatever you call it, right? We sit there with our headphones, and if a developer interrupts us, or someone else, or your manager, you will say, now I need 15 minutes to get back into the zone. Like, people who do TDD, and it's very interesting, they all agree on this, we don't need this. So I went to a conference 2 years ago, and we were sitting, it was at Gran Canaria, so it was a software crafter meetup, and we were sitting at the beach in a nice round with like 20 developers, and someone brought this topic up. What do you think about the flow? And we are all agree immediately, so discussion was over in like 5 seconds. We don't want this. I want to go to my colleague and interrupt him now. to show them something. And if someone does this to me, I said, wait, give me a second, I just finished this test to make sure it's read. Okay, yeah, ask the question. So, really, try it. You don't have this need anymore. You just think from one test to another. You don't have to think further because you have the to-do list or you have your next test. So no, I will never close my laptop without having a failing test because I know exactly where to start next morning. And if I don't remember, I run the test, I will find it. And normally there's a test saying, Danny forgot me. This is what I added a message there. And if I ever commit this, my colleagues and the CI will tell me that Danny forgot something. So let's talk a bit about Android. So TDD is pretty big in the backend community. It is really big, for example, in communities like Ruby. So if you have a dynamic type language, you don't have types. So TDD is basically what we have as a compiler. So TDD is really big there. But Android developers always say, yeah, but it doesn't work for Android. And there are some problems. So thinking about this, what I showed earlier, right? You have like a test that inflates a layout, and you want to call on create. And does this actually work? Can I call in a unit test? Can I call on create on activity? So first, the moment you move to Kotlin, this doesn't compile because it's a protected method. It worked in Java. It's easy. You can cheat here a bit by using extension functions. You can download it from there. Let's skip this. But can you actually call this method, right? So now it's not protected anymore. Does this work? Actually, it does. In the early days of Android, it wouldn't. It would fail. But there is this thing called a mockable jar that is created in the background by the compiler. And it removes all the finals and all the code. So you can call an activity on create, and no code will run. If there's a return type, it will be null. The only thing you have to do is set this in your Gradle file, return default values. Otherwise, it will crash. That's very important. And so no code will run, and we are happy, and I did this for a long time. But actually, nowadays, we don't use activity in Fragment. They actually deprecate it. We use this app component, right? We use Jetpack. This is like a jar, this part of your project. Actually, code will run. So you can just forget what I just told you. So if you really want to test activities in fragments, you probably have to do dirty things like this. Okay, mock the fragment manager, mock the layout inflator, and all of those. The good thing is, you can only do this. You only do this once in your project, like here an extension function. And then what I do is normally say something like prepare for test. That's easy. You can do this. And then you can call on create. Sometimes you might have like weird crashes on Android because there's actually static code that's called that you can't even mock, which don't have static code. But sometimes, like here in TV, it was like this. Sometimes I really do things like this where we catch it. And again, download from there. I will not go deeper here. I'll show you the link later. The thing is, what I want to tell you here, as you can see, it gets really hard when you test Android fragments and activities, which are the lifecycle containers for those who don't know Android. So they are tricky to do unit tests with. So let's avoid using them. For example, use a lifecycle-aware components. So instead of testing an onStart method or an onCreate method, use like callbacks, lifecycle-aware callbacks from Jetpack. So testing Android views classes are hard, so don't do it. Avoid it. Use view models. View models encapsulate the state, right? Maybe we cannot test the activity, but everything from the view model on we can test. I definitely do this, and most developers are. This is much easier to test. So use view models. And there's one thing that a lot of Android developers disagree on. There's a thing called data binding, and I love data binding. And data binding makes it really easy for me to unit test. Why? I show you. So there's this, this is data binding. We have our layout definition, and we bind it directly to code. There is not this activity thing in the middle anymore. Because, why do I like it? Because it solves this one big question that we argue for years about Android. Who is the view? Like, remember, like MVP, MVVM, we always ask, what is the view? It's a fragment, activity, and actually view, right? Who is the view in MVVM? You know, the data binding is easy. It's an XML file. There is no definition of this view anymore, which is pretty cool. So what's left? What can we not test? Let's think about permissions. When we have an activity, we have to declare it in a manifest, right? And maybe we have to give some permissions to it for like the older devices. How do I TDD this, right? I have to write these things in a manifest. But I'm not allowed to write it without having a test for it. So you can kind of cheat. Class is not registered manifest as a warning. You can make it an error in the IDE. And then you have a compiler error, or you can set it in as a lint option and make it an error. So it's really valuable if you have these tools called lint, detect, and all of these Java tools that were before, and have like a zero tolerance. Make them all an error at some point. And the moment you have one of those, oh shit, doesn't compile. In your TDD cycle, you have to fix them immediately. So use the compiler. If you really want to test something weird in a manifest, a year ago they introduced this. You can actually get access to the merged manifest in Android by just setting something in a Gradle file. What's left? Like, remember the example? I didn't put anything in the layout file. Yes, so UI text sizes, button text. We still need like a real UI test for it. Or just open your phone and look at it, right? I mean, TDD will not prevent you from testing, do like a final check. You still need to do that. So we can talk about Espresso, which is our UI testing framework. So some developers say, you know, I do TDD with Espresso. I always have a weird face when I hear the sentence. The thing is, you have to be really fast with TDD. You need this fast feedback, right? I talked about seconds. Android builds are already slow. If you think about UI test, you're not talking about seconds anymore. So they continuously need to run. With Espresso, this will not work. So, wait, what is happening here? So, I'm not doing anything here. Okay. So test first. Yes, you can write test first with Espresso. That is totally fine. Are you doing TDD? No. But it's still fine. Test first is nice. So start with, there should be a login screen with 2 fields and a button. You can write this test, right? But it will not bring you TDD. But you can combine those two, which is nice. So let's talk about Roboelectric. If you're an Android developer, you might have heard of Roboelectric. So it was a framework that in the early days of Android allowed us to unit test. Because, as I told you, like a while ago, we couldn't set the smokable jar thing in the Gradle manifest. The problem was, and this is from a talk I gave many years ago at DroidCon Berlin, it was a very flaky framework. And I said back then, don't spend more time fixing your test setup than fixing your actual app. But what happened then recently, like last Google I/O, Google kind of took over the project and came back with Espresso. And it was basically like last Halloween, Roboelectric 4 from Google came out. And the question is this still valid? So when you ask Googler, how do I test this? They will say Roboelectric. So Roboelectric is back if you want it or not. So let's look at Roboelectric. The problem with Roboelectric is when you run a test, it will take additionally up to 8 seconds to run this initial test. It's not 8 seconds per test, but the initial one. When you use the activity test rule, it's even more, which is the one that they recommend. And Stefan Nicolas from Square, I talked about this like when I was in San Francisco last month. He said they realized like every test takes hundreds of milliseconds, every single one of them. It should be 2 or 3 milliseconds per test. So this sums up if you have thousands of tests. So Android builds are already slow. So should we use Roboelectric? You know, when you actually listen closer to the Googlers, they're actually trying to replace some of your Espresso tests and move them to Roboelectric. So they treat Roboelectric as like a virtual device. And not the way we sometimes think about it, like moving our unit tests. So unit tests are here, and UI tests there. Move your UI tests to Roboelectric, make them faster, and not make your unit tests slower. There's a lot of problems. They're not compatible with JUnit 5. It is still slower, as I told you. And yeah, it replaces Espresso, not VM test. So sometimes you have to have the need. So this Friday, I added a crying smiley to one of my pull requests because for the first time in a year, I had to write a Roboelectric test. And I was really sad about it, but I needed something that tests a lot of string resource building, and it was just easier to write a Roboelectric test. But build speed is important. So one rule maybe, have them in separate folders. Have test, Android test, and maybe like a shared test, which is, because Roboelectric is kind of an integration thing, right? It's between the two ends. You know, TDD, think about limitations. Custom views, animations. At Viacom, we tried to test that we gave up. That gets just ridiculous, the amount of code you have to write. So sometimes be pragmatic and don't test that. I want to have one more word about mocking before we close. Because mocking became like the one thing that we developers do a lot. Probably use Mockito or one of those, and you have it all over your code base, right? The thing is, mocks make actually our tests very flaky. And when you watch people doing TDD, they're using far less mocks than you would normally use in your unit test. I found it very interesting. So the thing is, what you should do is, from my point of view, mock more your outside dependencies. And so think about modules as a dependency, like Gradle modules, for example. Because TDD will change the way you test. So this is a classical approach. Class 1 has a test 1. Class 2 has test 2. This is what we did. This is how we got taught unit tests for like a decade, right? You're doing one test at a time, and you mock everything around it. Actually, when you're writing TDD, something like this happens. Because you're writing a test, and then in the refactoring, other classes appear. But you will not change the original test. Why should you? Don't touch the test. It's working. It's green. There's no reason to touch it. So from class 1, these classes appear in TDD. So that's not the same picture anymore. So I give you an example. So the last company I worked for, we had something like this. We had like a test. I was testing my view model, and there's like a repository and an API layer behind it. And I was testing this view model, and everything evolved from there. And I had a lot of tests. And then this other developer came, and he added like a Redux part. In the middle of it, over the weekend, he opened this huge pull request. Hey, I added Redux. And the funny thing is, all the tests still worked, although he completely changed the architecture. So this was a very robust test suite. Maybe at some point we shouldn't test the whole API layer that have some dependencies, right? But you probably say, you know, this is not a unit test. I've learned unit tests. What you're describing is an integration test. So that's an interesting discussion, and I had it so often that I wrote a blog post about it. But I give you like a small overview. Kent Beck in his TDD book does not use the word unit test a single time in the whole book. I found it very interesting. Also, a lot of the older developers say unit back then meant more like a black box. It never meant class or method in the first place. That is something that came later when we tried to evolve this method. So the thing is with TDD, we test behaviors. That's why it's nice to test the view model. You test what you actually want to test, what the customer needs. And the rule here is, what your software does is actually stable. It will not change. But the way, as I just showed you with the Redux, the way you do it is unstable. This changes all the time. A new architecture component comes up. Oh, let's replace the database. But if you have, depending on database, if we would have like tests for like all these components that I showed you, right? The Redux store and all of those. The moment you change this, you can throw away these tests. And in the beginning, I told you about my long journey to TDD. This is what happened. I realized I write so many tests, and tests should enable refactoring for me. But then when I refactor, I have to delete the test. But if you have to delete the test, something is wrong. And it took me a while to figure out what's actually wrong there, because I believed the test. And TDD showed me the tests were wrong. And mocking is a big problem. Do we have time for this? Here we have 3 more minutes. So one word for code coverage. A lot of developers looking into code coverage. The thing with TDD is, code coverage is like a side effect. So ideally in TDD, because you're not allowed to write any production code without a test, you should have 100% code coverage. But it's like a side effect. It's probably not 100% because there are some things we can't test. But you know, if you have a team that does TDD, you don't look at this because we know what a false metrics this is. And I remember like when we went to Kotlin, the code coverage tool couldn't do inline functions. Should we stop using inline functions because the tool told us so? I said, no, it's a bad tool anyway. Let's get rid of code coverage and let's do TDD. Like keep doing TDD. And if everybody doing this, you can't miss any code. So let's wrap up with some quotes. Kent Beck said, test only if you want it to work. I like this, yeah. If it's worth building, it's worth testing. And if it's not worth testing, why are you wasting your time building it in the first place? I like this one. So the thing is also with TDD, you have, and this is the question I get the most, like, what do I do if my product owner, my manager, comes to me and said, don't write tests, we don't have time. The thing is, if TDD is the way you're writing code, no one can forbid you, because you can't write code without a test, even if you just do it for yourself. Because your code will be better by doing this way. And Uncle Bob always said, when someone comes to this argument, he said, no one would go to the doctor and say, so you wouldn't go to the doctor in a hospital and say, wait, can you do this operation without this part? No. Trust the craftsman, right? He learned that. So we should trust as developers. And TDD and Android, it's possible. It is actually fun. And 2 resources. This is the original book from Ken Beck. This is a book that just came out, and I met like the authors last in the Android Dev Summit. So there's an Android TDD book now. I have 1 voucher code that I can give away for question later. Probably won't have time for this session. But if you come to me, the first one comes to ask me a question, can get a code for this book. And I have a lot of quotes. I will put the slides online later. And that's it. And thanks for listening. Spasiba. And Beck said, test only if you want it to work. I like this, yeah. If it's worth building, it's worth testing. And if it's not worth testing, why are you wasting your time building it in the first place? I like this one. So the thing is also with TDD, you have, and this is the question I get the most, like, what do I do if my product owner, my manager, comes to me and said, don't write tests, we don't have time. The thing is, if TDD is the way you're writing code, no one can forbid you, because you can't write code without a test, even if you just do it for yourself. Because your code will be better by doing this way. And Uncle Bob always said, when someone comes to this argument, he said, no one would go to the doctor and say, so you wouldn't go to the doctor in a hospital and say, wait, can you do this operation without this part? No. Trust the craftsman, right? He learned that. So we should trust as developers. And TDD and Android, it's possible. It is actually fun. And 2 resources. This is the original book from Ken Beck. This is a book that just came out, and I met like the authors last in the Android Dev Summit. So there's an Android TDD book now. I have 1 voucher code that I can give away for question later. Probably won't have time for this session. But if you come to me, the first one comes to ask me a question, can get a code for this book. And I have a lot of quotes. I will put the slides online later. And that's it. And thanks for listening.